So here's part 2 of the review for the midterm. This part is on sets. So let's start with number 18. The directions are determine whether the set is well defined or not well defined. So 18 says the set of professional baseball players over the age of 39. Okay, so that one is well defined because we gave it an age, right? Age over 39. So we could look at a player, decide if they're 39 or not 39, and that would put them in the set or not put them in the set. 19, same thing, well-defined, not well-defined. The set of people who wear expensive perfume. All right, keyword here is expensive. That's an opinion. So that is not well-defined because everyone doesn't have the same opinion of what expensive is. So what I think is expensive may be completely different than what you think is expensive, so we couldn't say whether or not something's in that set. Number 20 just says identify the set as either finite or infinite. So does this go on forever, or could I put a cardinality to it? So this says 2, 4, 6, 8. You can see definitely I'm doing even natural numbers, and you can say that is going to go on forever, so that makes it infinite. Number 21. Use the following table, which shows the average price for a new beverage that is served at a coffee chain. Let the 10 selected regions represent the universal set U, and then use the list to represent the set in roster form. Okay, so down here, so I can see here's all of my chain stores. I want the set of regions in which the average price of the new beverage is more than $5. So I'm just going to go through and say A is more than $5, B is more than 5, C is more than 5, D is more than 5. Not E, not F, not G, not H, not K, and not L. So just A, B, C, and D, and that would be B. All right, 22. Write the set in set builder notation. So right now it's in listing notation, 15, 16, 17, 18. I can clearly see what they are. Do you see how C is the same thing? There's no way that's the answer. Why would I do that? I wouldn't give me back the same thing. All right, so set builder notation is how to build the set. So you can see the other three choices all have the set of all X. Awesome. Such that X does what? So A says between 14 and 19. That looks good. B says between 15 and 18. Now that's a problem. Between does not include the endpoint, which would mean this one would start at 16. Let's get rid of that one. This says an integer less than 19. Well, no, because less than 19, I would keep going, and I have 2 and 3 and -5, right? I would have all those others. So let's get rid of that too and say this is a great choice, and that is the answer. 23 says write a description of the set. So we want to have a word description. So I can see my numbers are 4, 8, 12, 16, and 20. I'm moving by 4s, but I'm starting at 4. So we want to make sure this makes sense as I'm reading my choices. So option A says set S is the set of natural numbers that are multiples of 4. That sounds pretty good. B says it's the set of integers. No way, because it's only multiples of 4. It says set S is the set of natural numbers greater than or equal to 4, but that doesn't show the multiple part. Greater than or equal to 4 would be 4, 5, 6, 7, 8, so we don't want to say that one. And D, the set of integers that are greater than or equal to 4, that one doesn't make any sense either. So I can see this first choice, A, where it says the word multiples, is the right choice for us. I do encourage you read all the way through. I think sometimes on a test you get the jitters. I do too. I always tell my students, I'm like, I think if you had to take a driving test. I drive every day, and I've driven many more years than I want to tell you about. A long time, longer than you guys have been alive. So what I think is, even if I do a driving test, even though I drive every day, I get nervous, and then you jump to do stuff that you wouldn't normally do. Same thing on a midterm. So slow down. So even if you look at an answer and you go, oh, that looks good, read the other ones just to make sure, especially on multiple choice like that. Different when you're solving an equation, you get the answer and you look at, there it is, awesome. But the ones when you have choices and you're just thinking about it, read them all. Number 24 says find the number of elements in A for the set A where X is a month in the year. Well, we know there are 12 months in a year, so I'm reading through A, B, C, D, and I see 12 is for C, and so that's what I want to pick. There are 12 months in a year. 25 says the set of X. X's are natural numbers, and X goes from 15 to 23. All right, so here's a little tricky. Definitely, you can immediately get rid of B, get rid of C. They're way too big. It's not that many numbers. But look at A is 7 and D is 9 those are close, and neither one of them are probably what you're expecting, because I think you're all expecting the answer to be 8. You go 23 minus 15 is 8. That's my answer. No. You kind of have to add 1 when you do that subtraction. Or if it's something small, write it out. Okay, so here I wrote out 15, 16, 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9. The trick is when the numbers are consecutive, like 15, 16, 17, 18, whatever, when you subtract them, like you can, 23 minus 15, oops, I was thinking 8 in my head, so of course I wrote it, so let me get rid of that number, I don't want it. 23 minus 15 is 8, but you have to add 1 or you've skipped the 15. When I subtract it, it gives me how many come after 15, but I have to add that 1 to get the 9. Don't worry if it confuses you. You can always write them out if it's small enough so that you can get the right answer. Okay, on number 26, it asks you which of these symbols would make this statement true? So remember this one with the line under it means they could be equal. The one with the line slash through it means they're not. This means proper subset, so that there's something else on the right that wasn't on the left. And then I said both, or, you know, is it both? All right, so I can see 6, 7, 8 is in 5, 6, 7, 8. So definitely it's a proper subset because there's that 5 on the right that wasn't on the left. But if it's a proper subset, it's actually a regular subset as well. So it would be D. Careful with that, just because remember the line underneath means they could have been equal. This one is hardly ever wrong with the line equal. The proper one says that it's got to be bigger. So if things were equal, remember you got to use the line. If they're not equal, then both goes in, right? So if you can, pretty much here's what I'm saying. If you can use, let me use a different color. If you can use this, you can use this. That's what I'm saying. So I want to be clear on that. You're never going to pick this as your answer. If you can pick this one, you're going to pick both. Okay. Number 27 says determine if they're equal, equivalent, both, or neither. All right. Sometimes people tell me L is L, M is N is N, O is O. No, it's not. Think about your passwords that you put in where capitalization matters. Capitalization matters here. So because it's a capital L versus a lowercase l, they are not equal. Okay, so this is not it. They are equivalent. Equivalent says how many elements are in each set. So the left set has 4, the right set has 4. So since they both have 4, they're equivalent, and we're done. That's our answer. 28 says for the given set, construct a Venn diagram and place the elements in the proper region. Okay. So when I'm looking, I'm always going to start in the intersection. So I'm saying, what do they have in common? I see A and B both have an E, they both have a J. So I'm looking for an E and J, and I see it in both of them. But I could just go ahead and write it in here. And I will be giving you scrap paper, so if you need scrap paper, absolutely you're going to be provided with it. Then I is only in A, so let's put that there. N is only in A. D is only in B. R is only in B. But when I look back at you, I took care of D, I took care of E, I took care of J and I. I don't see M anywhere, so let's put it out here in the universe. I have N and I have R. Okay, so when I'm comparing these two, A and B, B has the M in the universe. Okay, 29, now I have a Venn diagram, it's already filled in, and I want to know what is set A. So A is this circle, everything in there. So it's 9, it's 2, it's 6. Nothing else, so don't add anything else from the other sets. Okay. A little trickier. This one says put A complement together with B. So everything outside of A needs to be included. So I see an F out here. I see this @ sign. I see a P. So that was everything outside of A. F, @ sign, and P. The B is the name of the set. But then I'm putting it together with B. So B had the @ sign, and it has this and sign, which I know I can't draw well, and it has an X. All right, so this is what I'm looking for over here to say that's my thing. So it's not A. It's not B. This one looks good. X, here's P, here's @ here's F, and here's and it's not that. So you're just having to look through and see, match it up. I have no problem like writing things out, making sure I got everything because I don't want to mess it up. These are too many points to throw anything away. All right, number 31. Now it's a word problem, but still set theory. So this says Monticello residents were surveyed concerning their preference for candidates. And the candidates are Moore and Allen in an upcoming election. Of the 800 respondents, that's my universe, 300 support neither Moore nor Allen, 100 support both Moore and Allen, and 250 support only Moore. How many residents support Moore or Allen? Okay, definitely we need to write something down, and let's see if I can give myself some room to write. I thought I was going to be able to write there, and it's just not going to let me. So let's kind of scooch this back a little and let's see if I can find some. Actually, I don't know where I'm going to write it. Let's see how this looks. Okay. So let's put a little M here for Moore. Let's put a little A here for Allen. All right, I know at the end there are 800 people. We'll get to that. So the number in the universe is 800. All right, 300 don't like either one of them. So that goes out there. So 300 don't like Moore, they don't like Allen. 100 like both of them, so that goes in here. Hope you can see that's 100. So we took care of the 300, we took care of the 100. 250 only like Moore, so that goes over here. All right, so I'm done putting my numbers in. Now let's look at what I have so far. I have 300, I have 250, and I have 100. So 300 plus 250 plus 100 is 650. I'm supposed to have 800 altogether. So when I do 800 minus 650, it tells me I have, I'll push it in like we had. So there's 150 here. Okay, so now my question is, how many of them support Moore or Allen? Well, it's anybody in these circles, the Moore or the Allen. So I can add 250, 100, and 150. Which is 500. Some of you might have been clever and figured out from before, and I always show you like how I think you guys are thinking, that if 300 don't like them, then the rest of them do. That would have worked too. You could use the complement rule there, but I don't think that's usually what everybody jumps to. I think you start saying, let's use the numbers you gave me. So that's absolutely fine, and that's probably how I would approach it anyway, especially on a high-stakes test like the midterm. All right, 32 says set A contains 35 elements, set B contains 22 elements. There are 40 elements in the union. How many are in the intersection? All right, so I don't know if you remember back to us doing this. Let's start with what would be obvious, is it would be add 35 and 22 to get 47. All right, and that's just what I obviously think. I say take A, take B, add them together at 47, but it says there should be 40. That difference between them, oops, and that's actually me not adding, right? So sorry, I didn't grab my calculator on that one, and you can tell 57, that helps. 35 and 22 is 57. Now I can do 40 minus 57, and that's 17. Okay. This number 33 says use the set statements to write a description of the shaded area. Use union, intersection, or complement. So when I'm looking at this, I see everything outside of A and B is circled, is shaded in. So it's not A minus B. Get rid of that. It's not A union B. It's actually the complement of that. A complement intersect B complement? Maybe. I can't tell just by looking at it. And A intersect B complement, it's not, because A intersect B complement would be the opposite of this part. It would be all of this stuff as well, and we don't have that. So let me erase that stuff I just threw in there. All right. So the only one that makes sense is this one. I want you to remember De Morgan's law. De Morgan's law said A union B complement. If I were to distribute the complement sign, it would change the union to intersection. That's a good way to look at this one too, that I can see it's A union B and it's everything outside of it. So the complement I could just write out this way. Number 34 says use the Venn diagram that shows the number of elements in the regions to answer the question. So I want to say how many elements belong to set A or set B. So that means I want to add these three numbers. So I have 15, I have 9, and I have 14. And because I messed it up earlier, let's jump right to my calculator and say that gives me 38. Okay. Number 35 says how many belong to A. Now remember, A is this whole circle. So I want to include the 14 and the 8, add them together, 14 plus 8, which is 22. So once again, A. All right, and here's our last one for the set theory. How many elements belong to set A and set B? Okay, here it is in the middle. That's my intersection, which is 9. All right, so come back later. I'm going to have a part 3 that will be on logic, but I hope this helps you get you set for the final, or not the final, my goodness, for the midterm.